Hi everyone, and welcome to Linux Administration. This is the first module on Introduction to Servers. If you have not already looked at the Introduction to Linux class, I would recommend starting there because that is going to be assumed knowledge for this course. For this course, we are going to be starting by talking about what is a server. A server is a computer that will allow us to have more users and have the computer give more information, and it will function a little bit differently than a regular desktop system. Servers end up being used all throughout industry. Now, some of the things that servers will give us is we can have multiple clients and they can have different functionalities and they can also share resources. That means when we have a server for a company, we would be able to have one server that is able to do multiple things. For example, web servers and file servers. And so we could have a server that is sitting there always on waiting for you to download files or look at websites. Now, servers are different than regular computers, so you can have a server on a regular computer, but that is going to have a couple of downsides, including the amount of power that you might be able to give it and the uptime of the server. So, a normal server at a company or a server that you might host at home is generally going to be more powerful. It is also not always going to have a GUI or graphical user interface. A lot of servers actually don't have monitors attached. So the only way to access the server is actually to remote into the server. Servers are likely to have networking capabilities and SSH so that you can get access to the server remotely. Servers have to be more fault tolerant and they must have more reliability. Fault tolerance and reliability is the way that a computer is able to stay running for a longer period of time and also be able to more easily deal with difficulties in terms of servers are less likely to need to be restarted. It is generally easier to add and update things on a server so that you can have the server running more often. Reliability means that the server is likely to be accessible to people more of the time. So, for example, mission critical systems will run on servers or mainframes. Mission critical means systems that can't go down. Some good examples of this. Let's say we work for a credit card company. If you have a set of servers that processes credit card transactions, it's not okay if that server goes down for even 5 minutes because that 5 minutes could actually lose you thousands or hundreds of thousands or millions of dollars. If you look at some of the larger companies, like for example Google and Amazon, Microsoft, if they have systems that go down for even 5 minutes, they end up losing surprising amounts of money. Servers tend to live in racks or in data centers, so rather than having just a single, for example, tower on a desk somewhere, a lot of times what you'll see is a metal structure that has a whole bunch of computers attached to each other rather than just sort of the traditional desktop tower. Servers also tend to have more powerful cooling systems. So, for example, data centers might actually have air conditioning running a lot more of the time. They might actually keep the data center 5 or 10 degrees cooler than the rest of the building to make sure that the computer doesn't overheat and extend the life of those parts a little bit. Servers could also reside in a cluster or a server farm. Modern data centers are actually considered clusters a lot of times. What you can see on these images are actually racks of servers. So if you walked into a very large company, this is something that you might end up seeing, and they would have a whole room dedicated to these computers. Now, we can have different kinds of dedicated servers. We'll be talking about that a little bit more later. But we could, for example, have a dedicated email server or a dedicated web server where the only thing that that computer does is run email or a website or something like that. Now, we can also have different kinds of servers. So, for example, if you work for a company and they have any variety of programmers or coders, the programmers or coders are going to need a server set up so that they will be able to work on their code. So we might have a testing server so that the code can be tested in an environment that's going to look like the production environment. We might have a staging server. This is going to be as close to the production environment as possible. Then we might have a production server, and these could be 3 separate servers all set up. Production is where the actual application would live. That I will give the warning because I just have to. Please do not test on your production server. You should be testing on your testing and staging servers. Testing on production is a slippery slope that you do not wish to go down. We could have things like application or database servers, where perhaps we have a server and the purpose of that server is to do things like hold a database of customers, or file hostings, where we want to host a lot of files or ebooks or something like that. We could have game servers. If you play any games, you probably have, like, for example, League of Legends. Maybe you have a server that you generally log into because that's where your friends or your guild happen to be. You could have, for example, a print server so that we can have one printer for an entire floor or office. We could have different varieties of communication or catalog servers. We could even have media servers where the entire purpose of the server is to give us the ability to share media with others. Server operating systems, some of the more popular ones in Linux, tend to be things like Red Hat, Ubuntu, and Debian. Red Hat is the one that you have to pay for. CentOS and Rocky are the free versions from the Red Hat company. But these are some examples of server flavors that you might end up actually seeing in industry that tend to be really popular. Now, there are going to also be Microsoft servers, but you'll be talking about those in other classes. Here, we're going to be sticking to Linux servers for the whole time. We can have single servers or multi-servers. A single task server does one thing. Multitask servers, they use time sharing to do multiple things. So if we have a single task server, it's really nice because there's a lot more simplicity and you can have a lower powered server. For example, you've probably seen Raspberry Pis and Arduinos and things like that, and you can actually run a server off of those, but those would be considered low power computers. So if you want to have something that is, say, hosting a website and hosting a database and hosting games and hosting files, you're probably not going to want to put all of those on a little tiny, say, Raspberry Pi. You're probably going to end up wanting a much larger server with more power for that. A multitask system allows us to do multiple things. Setup can be a little bit more challenging because lots of things are happening. There's more configurations or configs that you have to worry about, but it also is a lot easier to scale up. One of the big issues that you'll see in industry a lot is scalability. That means how easy is it for us to be able to take, for example, a server that is okay for 10 people and scale it up for 100 people? What about scaling it up for 1,000 people? What about scaling it up for 10,000 people? So the progression from 1 to 100 to 1,000 to 10,000 is the scalability and how easily we can do that. Will it still have the same amount of access? Will there be more wait times? Are we going to have more issues? All of those things are important. Most of these systems are going to be multi-user systems. The purpose behind a lot of servers is that multiple users can access them, so most of these are going to be multi-user systems. We also see a lot of distributed operating systems where the operating system is actually spread out across multiple computers. So, for example, when you are, say, Googling something, you don't go and say, I would like to Google on computer A or computer B. You just say, I would like to go Google this thing. And then you just let Google handle the back end of it. So, for all of the operating systems, it can be spread out on multiple systems, or it could be just on a single system. Now, previously, we used to have physical servers. Physical servers meant that you had all of this stuff that you needed happening, say the file server or the database server, on a single physical machine that you would go access somewhere. These can be harder to manage remotely. They might have lower power or resources. Scaling can get expensive and really time consuming because trying to make your physical server larger can be a lot harder. Then we have to start talking about, like partitioning and stuff. Virtual servers are actually a lot easier to manage remotely, so most of the world has gone to virtualization for servers and actually containerization, which we'll be talking about much later in term. Virtual servers are a lot easier to manage remotely, and they are also a lot easier to restart, reset, backup, things like that. A virtual server means that we basically have a section of the computer and we say this is now going to be our server, just like you would have a virtual machine. Instead of having a virtual machine of, say, Mint or Kali, you would have a virtual machine that is your server. You would be able to expand and contract that server as necessary because it's all virtual anyway, so it could just be pointing to more blocks or fewer blocks on your hard drive. It is a little easier to sandbox them because we can actually use some software to change that. There are some more specialized skills needed. So as soon as we start getting into virtual servers, we have to have some more specialized skills to the physical servers. But it's at the point right now where it's so common that everybody does most things on virtualization. It's not as big of a problem. Virtual servers also tend to be more portable, more fault tolerant, and they tend to be easier to back up. Because if you have a virtual server, you can have one sort of computer that has a whole bunch of resources. You can designate a specific section of that computer to a virtual server, and then you can say, hey, I would like to back up this server every day, week, month, year, whatever it happens to be, and then you can go send that somewhere else. We can also copy it a lot easier. So rather than having to, for example, take that server and do a backup and actually go somewhere to plug in a backup for that server like we would have to with a physical server, it's a lot easier to just point at that virtual machine and say back up the whole virtual machine. It also means because there's just a pointer to that virtual machine, we can easily move that pointer to a different virtual machine, which will improve our fault tolerance. Now, cloud servers and services are becoming more and more popular as we go, especially with the whole pandemic and moving to remote access for everything. Some cloud server providers include AWS and Azure. Those are the two really big ones. And then there's also Google Cloud Platform. Now, when we end up talking about the cloud, the simplest way to think about this is the cloud is somebody else's machine. So we can have, for example, cloud server software such as VMware Cloud, and that could be something that a very, very large company or government entity might set up so that they have a cloud service just for access for that particular government or entity or enterprise. We could also do things like with AWS and Azure, where we can actually buy pieces of the cloud and we can pay based off of bandwidth or storage space. And we can do things like AWS EC2 instances and have data buckets. We could use AWS or Azure to manage websites. And some of the things that's actually really nice about this is if you work in an industry, for example, healthcare, where you have to follow specific regulations and guidelines such as HIPAA, you can actually find service providers that are already certified for that. So because they're already certified, you have less steps that you have to do. So that was our introduction to servers. If you have any questions, please let me know, and I hope you all have a lovely day.